Good morning, Excel Geo. What we're moving on to today is Chapter 9, and I just want you guys to be aware that in Chapter 9, we're only going to be working with two sections, 9.1 and 9.6. We're going to do 9.1 today, 9.6 tomorrow, have a mini quiz on it on Friday, and then move on to Chapter 11. So in 9.1, you do have the printout note sheet that I posted, but I want to go over a couple of definitions before we get there. So in 9.1, we're going to translate figures using vectors. Okay, that's what we're going to be doing today. Now, the first thing I want to do is just go over a couple of terms. The first thing I want to talk about is when a transformation moves or changes a figure from one place to another, the new figure is called the image, and the original figure is called the pre-image. So let's just remember that our original figure is our pre-image. And this is before a transformation. Our new figure will be called an image. So our new figure will be our image. And that would be after a transformation. Now, so in that example, if I had a triangle, all right, guys, so if we have a triangle, and I transform that triangle, meaning, well, in this case, I'm just going to translate it. If I translate that triangle, in this case, I'm going to translate it. This is A, B, C. This here would be my pre-image, my original. Okay, and I'm going to translate it. It's going to go over. And then down. And that's going to be true for every point on that. And my new figure, A will become A prime, B will become B prime, and C will become C prime. That new figure will be my image. So here I have my pre-image. And here I have my image. And in the image, you're going to use the primes to identify the corresponding parts, like A corresponds to A prime, B corresponds to B prime, C corresponds with C prime. Now, the other thing we're going to look at is a term called isometry. And what isometry means, it's a transformation that preserves length and angle measurement. So it's going to preserve congruence. Is a transformation that preserves length and angle measures. Meaning, if this was an isometric transformation, triangle ABC would be congruent to triangle A prime, B prime, C prime, because all corresponding parts would be congruent. All right, so that would be an example of an isometric transformation because it preserves congruency. All right, guys? Now, what we're going to do now is extend this to vectors right now. All right, guys? So I'm going to take out that printout sheet that we have attached. Now, let me move my papers. Take out that printout, and we're going to look at what's our vector? Victor. What's our vector, Victor? We got a little rhyme there. Let me make sure that we see my sheet. I might have to move it a little, but I think we're there. So let's talk about this. We're going to talk about vectors first. And what are vectors? So that's where we're going to start. And if we take a look at what are vectors, all right, guys, we have a vector is a quantity that has both direction and magnitude. Okay, so a vector is a quantity that has both direction and magnitude. All right, guys? So I'm going to give you an example of what a vector will be. So I'm going to pick a point. I'm going to pick another point. And I can draw this. I'm going to draw this. And I'll give you my points so you can. This would be an example of a vector. This point here is 1, 2, 3, 4, 5, -5, -2. And this point here is 1, 2, 3, 4, 2. That's where I put them, just if you want to have some consistency. All right, guys? So let's take a look at this. If we take a look at this, guys, what we're going to do is we're going to name this vector. If I look at vector notation, I'm going to label this point A and this point B. Now, a vector will have an initial point and an ending point. Your initial point will obviously not have the arrow. The ending point would be the arrow. The arrow shows the direction in which we're going. So we're starting at A and we're ending at B. So in this case, my initial point or starting point of the vector is A. All right, that is that initial point right there. So you'll see that we're starting at A and we're going towards B. Now how we're going to write that now, and it's important to always put your initial point first. So when it says vector notation, it's not a ray, it's like a half ray. So you draw a line and the line goes up. So it's not a ray, don't draw a ray, it's like a half ray. That is the notation for vector. You always have to put your initial point first. And your ending point, in this case is B, second. Their ending point second. So this would be the vector notation, and you'd read that as vector A, B. All right, that's our vector AB. That's how I would read that. Now, what's important about a vector is something called component form. We're going to use two. Now, what's component form? Component form tells me the direction of my vectors. And component form is made up of two parts. Okay? It's going to be, it's going to look like a sideward V here, not a parenthesis, not a bracket, like a sideward V. It's going to be your horizontal component, comma, my vertical component. That is how we are going to write component form. So if we take a look at this, and this is how I'm writing component form, I take a look at vector AB. If I want to write vector AB in component form, so the component form of vector AB is, we have to look at your motion. You start at your horizontal component, your starting point. We start our starting point and we do our horizontal component first. What is my horizontal component? I start at A and I count over horizontally how far I have to travel. So if I take a look at that and I think of horizontal, I got 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 9, and I went in the direction right, which is positive. So if I look at that, that's 9. That 9, that is my horizontal component. So this is 9, and it's positive because I went right. So this is 9 here. That is my horizontal component. To find my vertical component, what I'm going to do is have to see how I go up. So from here, I count up. And if I look here, I started there and I went in the direction of up, so that is a positive motion. So that's a positive 4. So my vertical component would be 4. And that would be my component form for AB, 9, 4. And it's giving me the directions from A to B. I went 9 to the right, up 4. So I read it here, 9 to the right, up 4. All right, guys? So let's take a look down here. Let's name our vectors. So if I look here and it says name the vector and write the component form. Now remember, when we name it, we must always put the starting point first. Here, my starting point's B. C is my ending point, and I know C is the ending point because that's where the arrow is. Now, I name it then, remember half, not array, like a half arrow, and you put your initial point first, and C. Now the component form of that, we have to do our horizontal and our vertical component. I start at B and I count over horizontally first. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have a horizontal component of 9. Now I started at B and I moved to the right, so that would be a positive motion. So I put 9. Now take a look now. From there, I have to travel to C. From here I'm going 1, 2, but I'm going down 2. So because that is a negative motion, because direction matters here, that's when it says a vector is a quantity that both has direction and magnitude. Magnitude, I don't know if I said this before, represents size. So if magnitude represents size, it's representing the length of that vector AB. Direction is going to be that positive and negative. If we're moving to the right, we're going positive. If we're moving to the left, we're going negative. If we're moving up, we're going positive. If we're moving down, we're going negative. So because we went right 9 down 2, our component form would be 9, negative 2. Okay, now let's look at our next one. S is my initial, T is my ending, because the T is the arrow. So I write my vector formation, initial point first, S, T. And when we think of components, same thing. How do I get from S to T? What are my directions? I start at S and I go 1, 2, 3, 4, 5, 6, 7, 8. I went over 8 and I'm at T. But I went in what direction? I went left. I went left 8, so that is a negative horizontal component, negative 8. Now, since I do not have to go up or down to get to T, my vertical component will just be 0, identifying that we have no motion up or down. Okay, now guys, if you want, you can pause the video and then do the you try and come right back. Okay, guys, let's see if you tried down the bottom here. Name the vector and write the component form. Now again, initial point is R, so I have RS. Component form, I look at my horizontal. I start at R and I'm traveling 1, 2, 3, 4, 5 to S, but I traveled right, so that is a positive 5. I'm not going up or down, I do not travel a vertical component. I put 0. Okay, next one. Initial point is T. I'm traveling to X. I'm going from T to X. Horizontal, I'm not moving left or right, so my horizontal component is 0. My vertical component would be 1, 2, 3. I moved up 3. That is a positive direction, so it would be a 3, a positive 3 for my component form. Here, 3, my initial point is B. I'm ending at K. That is my vector name. Now, if I write component form, I'm looking at my horizontal and my vertical component. We're going to do horizontal first. I'm going over 1, 2, 3, 4, 5. I went 5 to the left. 5 to the left means that's a negative 5. Left is a negative direction. Then from here, I'm going up 1, 2. I'm going up 2. Up is a positive direction. This is a plus 2. So it's negative 5, 2. All right, guys, let's flip it over now. Let's do the second part of our lesson. All right, guys, let's do the second part of our lesson. All right, I think I'll move this up a little. All right, there we go. Now, vector translations. Translate a triangle with vertices 2, 5, -1, 3, 0, 4 by that vector. You can translate using a vector. A vector is just telling you the direction in which we're translating. So now remember, we have a horizontal and a vertical component. So we have a -2 and we have a +1. The -2 is going to represent my horizontal component, and the 1 represents my vertical component. So if this is my initial triangle, I have 2, 1, 2, 3, 4, 5, -1, 1, 2, 3, 0, 1, 2, 3, 4. This is my initial triangle. Let me move it over so you can see it. All right. So that means we're going to move it. Now that means we're going to use that vector. Our horizontal, meaning everything is going to move. -2 would be a horizontal component. That means we're moving, if it's negative and it's a horizontal component, we're moving everything 2 to the left. All right? 1 is a vertical component. 1 is positive. So we're going to be moving everything up 1. So if you look at this, the change of each x-coordinate by what? Subtracting what? Change each x-coordinate by subtracting 2, because we're moving 2 to the left. Change each y-coordinate by adding 1, because our vertical component is a +1. So if I take a look at this, the triangle will be shifted 2 to the left and up 1 to the following location. So that means every x-coordinate we're subtracting 2, every y-coordinate we're adding 1. So if I look at this, 2 minus 2 is 0, 5 plus 1 is 6. Again, -1 minus 2 is -3. -3 plus 1 is -2. 0 minus 2, subtracting 2 is -2. 4 plus 1 is 5. Now, if you graph this, I get 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 1, 2, oh, 3, -2, I'm sorry. 3, -2. And then it's -2, 1, 2, 1, 2, 3, 4, 5. And you'll see that every point moved 2 to the left and up 1. Now let's talk about image and pre-image. Okay? If I look at the image, my image will be my new figure. So the image is going to be my yellow triangle. My pre-image is going to be the original figure. So if I look at that and I say my pre-image is my original figure, my pre-image will be that first triangle. All right, that first triangle. All right. Now you try, guys. If you want to pause the video and try number 1 and 2, and then come back and play it when you're done. All right, guys. So let's take a look now. Hopefully you tried. Let's take a look at number 1. You're translating this, and I know it's a quadrilateral because it has 1, 2, 3, 4 vertices by this vector. What does it mean? The -2 is my horizontal component. The 5 is my vertical component. So this means I'm going left 2, up 5. So now let's take a look. If I looked at this, if I graph the first one, 1, 2, 3, 1, 2, 0, 1, 2, 3, 4, 2, 2, and -1, 1. This is my original. So guys, if this is the original, this will be my pre-image. All right, guys, this is going to be my pre-image. So we got this. This is the pre-image. I'm going to put it in orange since I know it's the pre-image. We're a little consistent. So that's my pre-image. Now we're going to move everything. So let's take a look at moving everything. Going left 2. Every point, if I go left 2, I'm going to subtract 2 from every x value. And going up 5, I'm going to add 5 to every y value. So 3 minus 2 is 1. -2 plus 5 is 3. 0 minus 2 is negative 2. Negative 4 plus 5 is 1. 2 minus 2 is 0. 2 plus 5 is 7. Negative 1 minus 2 is negative 3. 1 plus 5 is 6. So what we have here, I have my 4 points. I have 1, 1, 2, 3, negative 2, 1. I went 0, 1, 2, 3, 4, 5, 6, 7. And negative 3, 1, 2, 3, 1, 2, 3, 4, 5, 6. So if I take a look at that, this new one would be my image. And you can see that every vertice moved left 2, up 5. All right? Now let's take a look at number 2. Same concept. This one I know is a triangle because I have 3 vertices. And I'm moving it by the vector positive 3, negative 1. 3 is my horizontal component. Negative 1 is my vertical. So I'm going to go right 3 and down 1. All right? So let's graph. If we take a look at that, I'm going to first graph my original. I got negative 1, negative 2, 1, 2, 3, 4, 5, negative 2, and then 3, 1, 2, 3, 1, 2, 3, 4. So we have this triangle down here. And we're moving everything right 3 and down 1. So now if this is my original, that will be my pre-image. So I'm going to do it in orange so we can identify the two. That is my pre-image. So now let's move everything. Right 3, down 1. That means I'm adding 3 to my x value, subtracting 1 from my y value. Negative 1 plus 3 is 2. Negative 2 minus 1 is negative 3. Negative 5 plus 3 is negative 2. Negative 2 minus 1 is negative 3. 3 plus 3 is 6. Negative 4 minus 1 is negative 5. So you're having 2, 1, 2, 3. You're having, oh, I'm sorry, that was negative 2. I did negative 2, negative 3. Now I did 2, I'm going to do positive 2, negative 3. And then I'm doing 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And there's a little overlapping. But you'll see now I have my image after my vector translation. So that means my image, no, it might be a little hard to see because there's overlapping, but I will try, and that would be my image. Okay. All right, challenge problem. And it's actually not so bad. It says these are my vertices of the triangle. These vertices were translated by the vector negative 3, 4. What were the original coordinates? That means this is my image. They want the original. They want the pre-image. That means you're going to do the opposite of the vector in which they gave you. So that means I went left 3, up 4 to get to these points. So to get back to my original, I'm going to do the opposite. To get back to the original. All right, guys? So we're saying back to the original. I'm going to then go right 3 and down 4. So if I look at my original, if I'm going to add 3 to my x, subtract 4 from my y. So I'm doing 5. 2 plus 3 is 5. Negative 3 minus 4 is negative 7. Then I have negative 4 plus 3 is negative 1. 1 minus 4 is negative 3. 0 plus 3 is 3. 2 minus 4 is negative 2. So now watch what happens here, guys. So I'm going, if I graph this, I have 1, 2, 1, 2, 3. I have 1, 2, 3, 4, 1. And I have 0, 2. This here that they gave me is my image. This is the image. They gave me the image and they wanted me to find my pre-image. So this here was my image. and I found my pre-image. So when I graph this, I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, negative 1, 1, 2, 3, and then 1, 2, 3, 1, 2. This here would be my original, that pre-image. So I went backwards. I found the opposite. All right, guys? So this here would be my pre-image. All right? All right, I hope you guys, that helped you today. So now what you have now is another sheet. All right, guys? This is your exit ticket. All right, guys, just try your best on this, and I will post the answers on it tonight. Just wanted to see if you understood what was going on. And then this is your homework, and these 2 graphs if you need it. You could also just do it on a separate sheet of paper. So I will, there are some problems that are even in here. I will post the answers to all of this tomorrow. And if you have any questions, please come to my office hours. I'm going to be using Google Meet now because a couple people had trouble last week with the Canvas conference, wasn't allowing them to load in. So if you have any questions, come to my Google Meet, and then here's your assignment for the day. All right? Talk to you soon, guys. Have a good day.